A marine sandglass is a timepiece of simple design that is a relative of the common hourglass, a marine instrument known since the 14th century. They were employed to measure the time at sea or on a given navigational course, in repeated measures of small time increments. Used together with the chip log, smaller marine glasses were also used to measure the boat speed through the water in knots. Although vital to maritime navigation, marine glasses were not accurate measuring instruments for the passage of time. Many design and environmental factors could affect the duration of sand's flow, and therefore its reported time. Their use continued through the early 19th century, when they were supplanted by reliable mechanical timepieces, and by other advances in marine navigation. Marine sandglasses were very popular on board ships, as they were the most dependable measurement of time while at sea. Unlike the clepsydra, the motion of the ship while sailing did not affect the hourglass. The fact that the hourglass also used granular materials instead of liquids gave it more accurate measurements, as the clepsydra was prone to get condensation inside it during temperature changes. Seamen found that the hourglass was able to help them determine longitude, distance east or west from a certain point, with reasonable accuracy. Design and use: marine sandglasses originally consisted of two glass bottles, one inverted above the other, connected by a small tube, with the ends wrapped and so joined together. Over time, the later progress in the art of glass blowing allowed them to be made in a single piece. The marine glass was filled with sand or a suitable material such as finely ground eggshell, lead or tin chips. This flowing material was chosen with two main objectives: to avoid the humidity and to absorb motion, both required for shipboard use. Placed in the upper half, the sand would flow slowly and steadily towards the lower half by the action of gravity, taking a certain time to empty. Once the upper portion of the glass was empty, the glass could be turned to measure another time period. History, Antiquity. The origin of the hourglass is unclear, although unlike its predecessor the clepsydra, or water clock, which may have been invented in ancient Egypt, the first referenced use, according the American Institute of New York, the clepsymere or sandglass was invented at Alexandria about 150 BC, according the Journal of the British Archaeological Association. The so-called clepsymere were in use before the time of S. Jerome, and the first representation of an hourglass is in a sarcophagus dated circa 350 AD, representing the wedding of Peleus and Thetis, discovered in Rome in the 18th century, and studied by Winckelmann in the 19th century, who remarked the hourglass held by Morpheus in his hands. Middle Age. Then it disappears until it has been reintroduced in medieval Europe. By the 8th century it is mentioned by a monk named Louis-Prand, who served at the cathedral in Chartres, France. But it was not until the 14th century that the marine sandglass was seen commonly, the earliest firm evidence being a depiction in the 1338 fresco Allegory of Good Government by Ambrogio Launzetti. Use of the marine sandglass has been recorded since the 14th century. The written records about it were mostly from logbooks of European ships. In the same period it appears in other records and lists of ships' stores. The earliest recorded reference that can be said with certainty to refer to a marine sandglass dates from circa 1345, in a receipt of Thomas de Statesham, clerk of the king's ship La George, in the reign of Edward III of England. Translated from the Latin, the receipt says, in 1345. The same Thomas accounts to have paid at Liscous, in Flanders, for 12 glass horologes, price of each 4½ gross, in sterling nines. Item, for 4 horologes of the same sort, bought there, price of each 5 gross, making in sterling threes. 4d. Another reference is found in an extensive inventory of the property of Charles V of France in his possession at the time of his death on September 16, 1380. One item is an hourglass from the king's study at his castle of Saint-Germain-en-Laye, described as follows. Item une grande horloge de mer, de deux grands files plaines de sablon, en une grande estouille de bois garnie d'argile. Item a large sea clock, with 2 large files filled with sand, in a large wooden brass-bound case. Importance in navigation. In long-distance navigation through the open ocean, The sandglass or glass used to measure the time was a tool as important as the compass. Filled with the amount of sand suitable for measuring a lapse of half an hour, each time the sand emptied was also called a glass. 8 glasses defined a watch. The times determined by the sand glass, along with the record in the logbook of the speed measured with the chip log, permitted the ship's navigator to plot his map position. Multiplying the ship's speed by the time the course had been kept, gave travel distance, a simple, overall method termed dead reckoning. The marine sandglass was critical for maritime navigation before the 19th century. At the beginning of that century it became possible to navigate by the lunar distances. Prior to this, dead reckoning navigation based on sandglass determined times was used, alongside determination of latitude using the quadrant. This was the only system available to mariners to navigate the globe. The parallel use of relative time measurements at sea, and time measurement by mechanical clocks on land continued from at least 1350 to 1805, that is, for more than 450 years. Although vital to navigation, the marine glass was not an accurate instrument to measure the passage of time. The design of the glass affected its accuracy in time measurement. The uniformity and fineness of the sand, the inner diameter of the connecting tube, and design aspects allowing wear that would affect the flow of sand all could contribute. In addition, many shipboard factors could affect the duration of sand's flow and therefore influence the time measured, including the humidity inside the glass, the ability for it to be positioned in a perfectly vertical position, and the acceleration or deceleration of the ship's movements. Finally, the use of short-duration glasses to measure long periods of time introduced further error. Marine glass use was supplanted by reliable mechanical timepieces, and by other advances in marine navigation. Watch sandglasses were used on ships to measure watch times, typically in half-hour periods. The helmsman or ship's page were the crewmen responsible for turning the watch sandglass, thus applying the time to be registered on the ship's log. Watch measurement began with the sun reaching its highest point its zenith at midday, which was likewise the essential time reference point for navigation. At that point in time, the ship's bell was struck 8 times. After the first glass had emptied, the ship's bell was struck once, after another glass, twice, and so on until 4 hours after midday, when it was again struck 8 times. At that point, a new watch began, and the sequence was repeated. Hence, in the voyages of Columbus, there are records that his crew logged the passage of time using a half-hour impoliter that was turned every time it emptied to keep track of the canonical hours. Likewise, during the voyage of Ferdinand Magellan to circumnavigate the globe, 18 hourglasses from Barcelona were in the ship's inventory, after the trip being authorized by Emperor Charles V. Ship log sandglass. From the 16th century a smaller glass was used along with the chip log, to measure the speed of the vessel over the water. The procedure was as follows. A sailor ran the chip log and another sailor the sandglass. The slide that pulled over the stern and let run the first length of line till the quadrant was stabilized in the water. The sailor was leaving to run the line to pass freely, leaving the slide by hand and touching the first knot sang mark. At the moment of the inverted glass and time began to run while the line was counting the knots as they passed until the sandglass sang mark. A second blow when they had dropped all the sand, then he caught firmly the line, measuring the fraction of knot elapsed to the last mark. And cried PE 5 knots and 4 fathoms. See also, water clock, hourglass, references.